Now, let's assume the simple scenario where we have Log4j directly integrated in a software that we can control. Where that particular library is deployed, it could be in a build file, it could be in an artifact that is already built, so we need to trace it back to the build file where that artifact gets built, or if we're lucky enough, we know exactly which piece of code through an SCA analysis like the one we do in Phoenix Security with reachability analysis, so we know that this code is actually included in the build file and not just declared in the particular line of code, include log4j, but then nobody calls that particular function, and hence the build file end up not having log4j. So if you scan the code in itself, and this is a concept called reachability analysis, we have other video that I'm going to post in the comments. If you have a code that call log4j, then that log4j will be in the build file. If you have not a code but an include, any system that scan the code in itself without reachability analysis will give you what we call a false positive. But let's assume we have an artifact that get built by a build file, and the build file get built inside the code, and log4j is actually used by the particular software that we're using. So that will end up in a container. In the most modern world, any piece of software that runs in your system will normally be included inside a container, and then the container will be deployed either in a registry, in an artifactory that is a store of images, or a container registry or a container image. Now, that image can come directly from how you build it, or it could come from any source that somebody else has published. So you might download a container, or you might build a container with another piece of container that has log4j. So the library might be inside a container that you download from an AMI that has, for example, log4j.